All right, so we'll start with the today's session. So we are going to cover the problem based on the third week topics, that is nomenclature of the stereoisomers, and particularly R and S nomenclature as well as the D and L nomenclature and the relative comparison concepts. So yeah, these are some reference books you can refer for these topics which are covered in the entire stereochemistry course. First, before going back to the doubts, we'll just look at here some questions asked in the uh, NPTEL portal. So in this question, can you explain the SN2 reaction with the
అన్ని
special?
చెప్పేశాను కదా నాన్న.
Just mute. All right. So this SN2 reaction with the special configuration to the substrate molecule. So we'll see what is the question. So probably this person want to know about the SN2 reaction with the spatial comparison. So for the SN2 reaction, I will just show what you mean by SN2 reaction. SN2 reaction is, let's say if I have the Rx and one nucleophile, let's say Nu minus, and in this step, the nucleophile attack backside on the substrate, and this leaving group leave the substrate, and it forms an intermediate step in which the nucleophile, the substrate R and the leaving group are attached to each other with the partial bond formation, and in the next step the nucleophile and the R, this product is getting formed. So in this one, the substrate as well as the nucleophile both are involved in the reaction mechanism. So that's why it's a bimolecular reaction, right? So this is one molecule and this is also the second molecule. So that's why the nucleophilic substitution and the 2 is stand for the bimolecular. In this, there are 2 molecules are involved in the rate determining step. Just always remember rate determining step. So in the rate determining step, these 2 molecules are involved. So that's why it's called as the SN2 reaction. So this is general mechanism of the SN2 reaction. And if you look at the stereochemical aspect of the SN2 reaction, then I'll just draw some simple example. Let's say this is the carbon molecule and it has 2 bond in the plane. Let's say this is A and this is B. Also, it has some a bond D which is attached, which is on the back side. And let's say here there is a atom. We called it as better for our understanding. Let's say it's E. So this carbon atom containing which has 4 different groups or the atoms. This AB is A, B, D, and E may be the atoms or the groups, but they are 4 different from each other. And let's say I have a nucleophile. Nucleophile, you can take any nucleophile like in this reaction, I will just take this simple example of the nucleophile Na plus N3 minus. So this N3 is our nucleophile here, and let me just attach here the it be probably the, let's say, bromine in this step. So when this molecule react with this nucleophile, it attack from the nucleophile, that is N3 minus, which attack from the backside of this CBr bond, right? And this CBr bond start breaking. So in this one, what happened? The intermediate step is formed, in which the carbon and the bromine, the front side there is the E group, and the back side there is a D group, and this nucleophile, which is start forming the bond, which is exactly opposite to this B or the bromine group, right? So in this position, what happened is delta negative is like this, because this negative charge is getting involved in the formation of the partial bond in the intermediate step, and the bond between the carbon and the bromine, it start breaking, and now it in the form of partial bond. It's not the fully carbon bromine single bond, so that's why it start breaking. And in the next step, what happens? This bromine it entirely get kicked out, and if you see the molecule after formation, so this molecule involve the A, which is will be remain as it is. This E will be shifted here, and this D as well as the, so on this side, this nucleophile, let's say this N3 minus will be here. So in this way, the stereochemistry of the product is getting changed entirely, right? Because of the attack of the nucleophile takes place from the exactly opposite side. That's why the stereochemistry, let's say if it is R configuration, the product may contain the product will be the S configuration. So that's why in SN2 reaction, the configuration of the starting material and the product is opposite. So this is the question. So hope you will you have get the answer of this question. So this one is the clear. The next question is what happening at this video or the isomerism. So I have tested already photos for the isomerism, but I'll just like to uh, just quick, I will give some review. Isomerism is like the compound has the same molecular formula but different structural formula, or this kind of, we generally, I mean, you have read about all the theoretical definition of the isomerism. So there are mainly different kind of isomerism. One is the structural, and I'll just drag the quick that images here, so that we can save our time for solving the next some problems. I think I can open that screen actually here. So hope you are able to see my screen. So see, so this is the isomerism, and there are different type of the, you can see here the structural isomer, and structural contain the chain isomerism, in which, let's say, the example of the N-hexane and 2-methyl propane. So in this one, this is also the one example of chain isomerism. The position isomerism, in which the position of the functional group, let's say the 2-bromobutane and 2-bromobutane and 1-bromobutane. So this is the like the position of the functional group is different. So its functional or the sorry positional isomer. The functional isomer is like the compound have same molecular formula, all are same, but let's say the aldehyde and the alcohol, or which I mean this. Let me show with the example, with the help of example. So see here the the example of for the functional group isomerism is the I'll put it on presentation mode. Let's say I have for molecular one structure which having CH3, CH2, and C double bond O H. So this is one compound which contain, we can see one, two, three carbon. Hydrogen is 6 and 1 oxygen. So with the same, see, this structure have the same carbon. One, this carbon is 3, second and third, C3, H6 and O. So C3H6O, C3H6O, both are having the same number of carbons, hydrogen, and oxygen. But you can see it's aldehyde and this is the ketone. So these are the functional group isomerism. The metamers are like the position of the bonds are double bonds, maybe different. Tautomers are like keto-enol tautomerism. Let's say I will draw here. Uh, this is the enol. Uh, so this is one isomer, and it can convert into the in the form of enol, right? So let's say CH3, C double bond. So this is the keto form, and this is, you can see this is the enol form. So this is the keto-enol tautomerism. This is keto-enol tautomerism. So this is also the one example of tautomerism. And ring chain, let's say a compound having the example of the, we can say, so this is one isomer, and this is one molecule which has the isomer. In this way, you can see the attachment of this bond like this. But in the with the same molecular formula, there may be the possibility of like this isomerism, right? Like this structure also can possible with the same molecular formula. So we can see this chain, this ring is different, and this ring chain is different. So this is also one kind of isomerism, and different. I mean, there are a lot of other isomers as well. In the due, I mean, progress of the course, or probably in the future, you may find the different kind of the isomers. And in the stereoisomer, which also called as the constitutional isomer, uh, and in these stereoisomers, there are geometrical isomers. Let's say here is the A, and here is A, B. This is the trans isomer, in which the AA, we can see that the same group are attached at the different position. Here A and A are opposite, attached opposite to each other. But its isomer is, this is the trans isomer, and the E isomer will be the A on the same side of the double. Here we can see the A atoms are on the on one side. They are not opposite each other. So this is the trans. Sorry, this is the cis form. So this is the cis and trans form. Also there are E and Z. So this is the geometrical isomerism, and the optical isomer that we are generally now we are studying, that RS. Some compound have R configuration, some compound have S configuration. Also in case of the amino acid, we have seen some compound have D nomenclature, D, L. So this all comes under the optical isomerism. So this is the one. Sorry. This was the one question doubt from someone asked, what is the isomerism? So this is cleared. The next doubt is how to identify Soher's formula in staggered and eclipse form. Soher's formula in staggered and eclipse form. Uh, what exactly you want to say? Can anyone is he here joined? So can you please just elaborate your question? Probably he is not here in the meeting. Let will I will reply him in the mail based way. So we'll go for our problems. So does anyone have any question? So we can cover it now, and further we go for the problems. Please let me know if you have any doubt or anything from the whatever topic you are covered in this course. One question is there. So explain question 9 in the assignment 1. All right, I will just open the assignment 1. All right, so this is the question 9. Am I right? This is the one question you are asking. Hmm, assignment 9. Let me just open assignment 1. Oh, the current assignment you are talking about. So if you are asking current assignment, then definitely I will not help you because these are uh, the current assignment I can't solve. Uh, we don't have the permission to solve the current assignment. If you have any question from this assignment, whichever question I have taken, I can help you. But we'll look for the question, what is the question actually in a current assignment. So the assignments. Oh, the week 1 assignment solution is also arrived, so we can solve, I think. So where is the week 1? All right, we can solve the week assignment, the question from week 1 assignment. Question 2, sorry, question 9. Are you guys able to see my screen? Hope you are. Can you just one confirm if you are able to see my screen or not, so you can solve this question. So I will just take this question on the presentation. So this is the question you want to solve, right? All right, I'll just. So this is the one question someone. I'll just take the options as well, so we can eliminate one by one options. All right, so this is the question, right? Can you just confirm once so we can solve? So this question, the correct Fisher correlation formula for the following compound. See, they have given the, oh, all right. I know where is the issue. So this they have given the 3-1, probably this is the typing mistake. But here also we can we can solve. See, these are the question. This question they have given the carbon atom which has the four different groups or the atoms, right? This carbon is the chiral carbon atom, and as we know, we generally write the structure in the form of there will be a one bond which is in the plane. Sorry, two bond in the plane. One bond is the below the plane, and one bond is above the plane, like this way. But if you goes to the more deep in the stereochemistry, then there will be a not necessary every time the structure will be given in this format only. So structure may present in this format as well. So here we can see we'll give the numbering first. This is the first carbon first group. This one is the second, and this one is the third, right? So in this one, we have to look at this is the fourth number carbon atom. So fourth number group, fourth priority group. So we have to look from the back side, right? If we look from the back side, then I will just draw the structure. The hydroxy group will be here. So hydroxy group, if you see, you need to imagine in this stereochemistry, you have the good imagination power as well. See, in this one, we need to see the molecule from the backside. And if you see the molecule from backside, then what happen? This hydrogen is away from the viewer, right? In this one, if you see from this side, so so the hydroxy group will be the on your right hand side. The methyl group is on the top, and this C2H5 will be on the left hand side. So we can write in this format, and you can see here it's R configuration. So the molecule and this hydrogen is away from viewer, right? In this one, although it is in this structure, it is written on the top, but if you look from the back side, this hydrogen will be the away from the viewer. So this has the R configuration. So we need to check the structure which has the R configuration. So we go one by one. This is the one, two, three. This R, right? But hydrogen is at the bottom, so R changes to S. So definitely this is not the option. In this one, this is the one, this is the two, and this is the three. One, two, three. This is R compression, and oh, it will not changes because hydrogen on vertical side. So this is the R compression. So this answer also given, right? This is the R combination. So this is the answer. And if we can also neglect this option as well. If you give the numbering 1, 2, 3, what happens? Oh, they are the same. So R combination. Oh, so these options are also the same. I think we have missed D option. 1, 2, 3. So this is the S combination. Obviously, this B option is the correct option. So this is the correct option. So get the answer for your if you have 3D model, then it will be easy for the imagination, because if you see here, generally we see the representation in this format, in which the A, B, C, D, these four groups are attached in this fashion. So one group at the bottom, one group at the top, and two group in the plane. So if you move further in the course, this stereochemistry, then there will be the representation in this format as well. So got the answer for your question? All right. So she got the answer. So we'll move forward for the. Anyone have any? Please let me know. We can solve or discuss. This is session only for the problem solving and discussion. You can feel free to discuss any doubt. The question, sorry, question 2 in assignment 2. All right. We'll go for the question 2 in assignment 2. Question 2. Oh, this is the assignment 1. All right, so this is the question. The correct assignment of chirality to the C1 and C4. Oh, sorry. All right, so this is the question, right? We just need to assign the stereochemistry, and the numbering also they have given. This is the C2 carbon atom, and this one is the C4 carbon atom. So we just need to give assign the stereochemistry for C1 and the C4 carbon atom. So we'll just draw independently this individual chiral center. So if you see this chiral center individually, so this OH is above, right? You can see here the oxygen is above. This hydrogen also above, and this hydroxy group is below. Sorry, should write it below. See, the structure will be like this, correct? In this one, probably the next atom I will draw with the little different shade. Sorry, it's not here. So this is the remaining molecule. In this one, if we give the numbering, this oxygen which attached to the carbon atom, which has the highest priority. So we'll give the numbering 1 to this one. The second number will be the hydroxy group, and third will be the for this CH2 this chain, right? And we have to look at to the molecule. Let's say if you look from this side, then we need to invert the stereochemistry. If you look from this side, we need to note, because if we are looking from the side of hydrogen, or we need to look from the downside. Since here you can see the visible, if you imagine molecule and look from this side, then definitely we can imagine the structure very clearly. So this oxygen which is on the right side, this is will be on the, if you look from this side. So this group will be on the right hand side, this will be on the left hand side, and this is on the bottom. So we move, if we check, this will be a clockwise, right? But we are looking from the hydrogen side, that is fourth priority group. So we need to invert the compression, that is R, we need to change it to S. Get clear? Please let me know if you are not able to understand. So the compression for this C2 is S. And if you move for the C4, then we'll draw just the structure here. The hydroxy group is above, and this group we can see this attached to the chain which is downward below lower side, right? In the module it was taught in the different way. See, if you imagine the chain, so it has the fold. near here, right? Near the hydroxy and this carbon atom. I'm not sure what uh, if you look correctly on from correctly to this molecule, see, this is directed upward. This also directed upward, and this also directed upward, right? So we just need to follow the we can look from the this side as well as from this side. This stereochemistry all about the direction. So if you look from this side, so the configuration is definitely you can give the numbering 1, 2, 3. This is R, and sorry, this is clockwise. That is it should be R, but this fourth priority group is on the top, right? If you look from this side, on the side of hydrogen, the fourth priority group will be on the top. So the definitely we need to invert this, and it will be the S then. Let me, I have, I think, ChemDraw software. Better I will just show you with the help of 3D. Let's say I have one carbon atom, where it is, which has the, right, this is the structure, and we can see here the oxygen atom, here also the oxygen atom. The definitely the, probably in the module, I understand the method, but the way it was taught in the module is different. Exactly, everyone has the different concepts, so probably you can follow whichever it's I mean why it is not getting. I think in the module probably it was taught in the different way, but at the end it should be the correct option. Sorry, correct assignment. If you see, if I just give the numbering, let's say, uh, please. See, so this is the structure, and if I show you the structure correct option, this will definitely the, see, this is a structure, right? So if I just click on this and structure to name, oh, sorry. See, this is the S configuration. So we have assigned it correctly. We can check it like this, and there was somewhere option was there. If we can see in the 3D. So I just want to show that. Yeah, this is the one. Uh, where is the molecule? So see, this is the molecule. Let me just make it big. That is not getting big. See here. Uh, let's consider. Hope you are able to see my screen. And here, if you look at this, this red one is the hydroxy group, and that which this red one, which is the hydroxy group, and the backside that one is the O attached to the ring. And if you see the hydrogen, where it is the hydrogen and CH2 group. See, this one is the hydrogen and this one is the CH2, that part of the chain other. So if you look from the hydrogen side, we can here see, I'll just bring the hydrogen in the front. See, this is the 1, this is 2 and 3. This is our comparison, sorry, the clockwise, right? So we need to invert, because we are seeing from the side of hydrogen. We are seeing from this hydrogen side. So we need to invert this, and so the R, the clockwise the clockwise refer as a R and anticlockwise refer as a S. So definitely we are looking from the 4 priority group. We need to invert the comparison. So that's why the comparison of will be the S. So if you imagine the molecule in the 3D form, you will definitely get the correct answer. If you look at the next center, this one, you can see here, it is hydroxy, which is upside, and this group are in this fashion, right? So this is CH2O, and here it is the CH2, and that side it is hydrogen. And if you look from the here, you say, if you look from this side, that is, we are kept the hydrogen away from us. So if you look from this side, then this side chain, the CH2O will be on the right hand side to us, right? So the hydroxy first, the CH2, this is the second, and this one is the third. Hydroxy will have the 4 priority. So this, the configuration for this one is 1, 2, 3. It is R. You can see it is clockwise. 1, 2, 3. This is the clockwise. So the configuration for this second, C4 is R. So in this, you need to imagine the molecule in the 3-dimension form. Then and then only probably we'll get the correct answer. Probably in the module, maybe the method will be different, but at the end you have to imagine, and the assign correct configuration. So hope you got the answer for this one. So can you move for next question? Does anyone have any doubt? Please. Oh, we have to check the answer, correct answer. So this is the C2S and C4R. Yes, they have given the answer as well. And explanation they have not shown, but definitely the option is the A option, that is C2 have the S computation and C4 has the R computation, is the correct option. So we'll move for the next question. In this question, we have to assign the absolute computation of the following molecule. So the molecule they have given, in this one, you can see here, this is the front carbon atom, which has the iodo, CH3 and the chlorine group. And the back side there is, I will just try to expand the structure so as you can better imagine, the chlorine, bromine, and there is CHO, right? So this is the structure of molecule. I will just pull the backside carbon atom just away so we can imagine the structure. And now we just need to assign the absolute configuration. So we'll just give the numbering to this. This is the 1, this is the 2, and the backside carbon will be the third. The backside carbon, which has the third priority, and the methyl group has the fourth priority. And here just for simplicity, we'll look from the side of methyl. So if you look from this, I will just try to elaborate, write the structure in the better format. Right here, I have not changed the any stereochemistry. I will just try to write it in the simple format so you can easily understand here. See here, what is the structure, how you can see here. In this, I will just assign this as a, this is front, right? And this will be a back side. And these bonds are in the plane. I will just move the molecule in this fashion. Like I have just taken this to this side and this to that side little bit, just to get the good alignment and just to view molecule in the correct direction, so as we can assign it very easily. Or else we can also give the give prop numbering and assign comparison from here as well. Please. So here is iodine. So if we look from the methyl side for the fourth priority group, then we can easily give the assignment from this side and this on this structure as well. 1, 2, and the back side will be the third one, right? So if we are looking from the side of methyl, so 1, 2, 3, it's a clockwise, right? So the clockwise means R, which changes to S. Why it changes to S? This is because we are looking from the side of the methyl group. So the combination for this C3 will be the S configuration. And what is configuration for this C2? So in this C2, see the bromine. We just need to give the numbering. So it will be the 1, the CHO, the carbon having the oxygen, and the chlorine. Yeah, here is the issue with the numbering. We have to assign the numbering correctly. So I will just erase all the so the bromine will have the first numbering. So first priority. This group which having the chlorine and iodine, which get the second priority, because if you see here in this one, the carbon has 4 different group. One is the fluorine, bromine, carbon, which has the CH3 group, chlorine group, and the iodine group. And here the carbon having the double bond hydrogen. So in this one, we have to assign the numbering correctly first. This is because here the CHO, which that is CHO refers as the carbon which has the, we generally consider it as a 2 oxygen, right? Double, since it is double bond, so we can refer it as a 2 oxygen. And here which carbon which has the 1 chlorine and 1 iodine. So we need to give the priority in this. So please, anyone have any suggestion for this? So what you can, I mean, Can you see my screen? Let me check. So in this one, the first priority will be the bromine, second priority will be the fluorine, and third priority we have to give, which will be the definitely carbon atom, which having the which group? So the first, this one is the second and third. All right, we got one option. All right, carbon CH, C3 and CI, which has the third priority. So we can solve in that way. So the third and the CHO will be the fourth. So if you look from the top side, the fourth, the CHO will be the away from the viewer, right? So 1, 2, and 3. So it have the comparison, R comparison, right? Yeah, sorry, here's the fluorine and right. So if you look at from the top side, so we can keep away the CHO group, and the comparison for this will be the bromine will the first, the fluorine the second, and the carbon atom which have the iodine, chlorine, and methyl group, which got the third priority. So the if you see the rotation, it will be the clockwise. So it's R. So this is the C2 carbon, right? C2 carbon as having the R compression, and C3 having, we have already shown, it has the S compression. So we can tick the box. So this is the answer for this question. Or we can solve in other way also. We can convert this molecule into the Fischer projection formula. If you are, not able to visualize the molecule in 3-dimension form, you can simply just convert this molecule in the 3D form. So how you can convert this molecule into 3D, Fischer projection formula? So this will be the molecule iodine, chlorine, and CH3, right? The back side will be the, as we have already done, the bromine, fluorine, and this will be the CHO. So we just need to pull out the, where it is. I'll just take the new. So we just pull out the CHO to the upper side, the straight. So how, if you pull the CHO to the upside, then what will happen? So the upper one will be the CHO, and if you can visualize, then the fluorine on the right hand side, the bromine on the left hand side, and the lower carbon, carbon atom. This methyl we need to pull out in the back side. So if you pull out this, if you pull, then we need to just rotate and then pull, make. So first step we just, in this one, this tray, if you pull this, so what will happen? The chlorine, iodine, and the, sorry, the carbon chain should be the vertical, right? So we need to go one step more in this way. So this upper side will be there definitely in this manner, but the lower one we need to rotate this molecule by this one by the 70 degree or something. So what will have, sorry, 90 degree, not exactly 90 degree. We need to rotate the molecule by the 180 degree. So this methyl will be the for the lower side, and this iodine will be on that side. So how it will look like, the iodine, chlorine, and here is the methyl group. And the back side, the chain that will be remain as it is, that is CHO, chlorine, chlorine, sorry, chlorine and bromine. you know, right, this method. Probably somewhere professor also taught how to convert the this kind of Newman projection formula into the Fisher projection formula. So we need to convert the long chain in this manner and just pull this CHO up and this methyl straight. So if you pull like this in this way, so what will happen? The CHO will go upside, the fluorine will be this side, bromine, the CH3 will be lower, and this chlorine and iodine at the respective position. So in this manner, you can easily convert the structure in the. Just you need to follow this intermediate step. We just draw the molecule in this fashion, and followed by the we have just rotated this molecule, this carbon atom by 180 degree. We have not misplaced the bonds between these. So this iodine just move by 180 degree. The methyl also move by 180 degree, and chlorine also move by 180 degree. So we got this intermediate structure, and then we just pull this CHO up and this methyl group here. So we got this kind of Fisher position formula, and here we can easily give the numbering and the RS configuration also. So here 1, chlorine 2, and the lower side 3. So 1, 2, 3, it's R, and here the iodine has 1, chlorine has 2, and this upper group has 3. So 1, 2, 3, it's yes. So it's 2R and C3S. C2R and C3S. That is this option C is the correct option. Right. So next question is C2 3S and 3R tribromopentane is. All right. We have to give the find the correct structure for the which has the at the 2 position, that is at C2, it should have the S configuration. At 3 position, it should have the S configuration, and at C4 position, it should have the R configuration. But here, just see here, it is they have written small. It means, oh, sorry. This group and this group have only the difference in the configuration. If it has the R configuration, this probably may have the S configuration, or this both may have the SS configuration in this fashion. So these two groups differentiated from each other just only by the absolute configuration. Sorry, RS configuration. So we'll just give the numbering. So where C2 will be the, all right, C2, C3, C4, 2, 3, 4. All right, in this fashion. So we can give the numbering and comparison. Iodine will get the first priority. This long chain will be the second, and methyl will be third. So this is 1, 2, 3. It's R compression. R changes to S. So this is the S configuration. The lower we'll give first. 1, 2, 3. This is the S, which changes to the R. All right, it has the C2S and 4R. All right. So in between, what is the compression in this one? So this one have the compression. Iodine will get the first priority. See here, the atoms and all are the same, but only where is the difference? Only difference is in between the configuration of this, and the R configuration has the priority first, right? As compared to the S configuration. Probably you have remembered in the rule, there is one rule for such molecules in which the R configuration which get the higher priority over the S configuration. So in this one, the R will have the second priority, and the upper part which have the third priority. So the configuration will be 1, 2, 3. It's R changes to S. So it has the S configuration. So the option A is the correct option here. And if you look at the other options, So therefore the the lower part. So does anyone have any doubt on this one, how I have assigned the comparison here? So just I did the comparison like one, the second group, I just give the second numbering for this lower side. This is because it has the R compression, and the upper group have the S compression. So this will be the third one, and the remaining obviously hydrogen will be the fourth. So if you see this 1, 2, 3, it's R, which changes to S because hydrogen on the horizontal side. So the option A is the correct option. So you can, if you wish, you can solve the other as well. So definitely the middle one have the different, or the other part will have different computation. So here 2S, 3S, and 4R will be the option A is the correct option. And also there are some question like the simple question, C2 carbon in the following is whether it is chirotopic, stereogenic, or the achirotopic and stereogenic, or chirotopic and non-stereogenic, or chirotopic and non-stereogenic. They are just, I mean, theoretical question. You can just uh, look for this. So which carbon atom? C2 carbon, this carbon atom. All right. So this is definitely the chirotopic carbon atom, because this one and these two condition for chirotopic carbon atom is this A, B, this AB should be the different, and the X may be the identical. So this is the chirotopic, right? If you replace this X by any other atom, let's say the Y, then this carbon atom become the chiral carbon atom. So that's why it's a chirotopic carbon atom. So the chirotopic. So the option A and D are the correct option. And again, this is stereogenic and non-stereogenic. So obviously, this is the non-stereogenic because these are the same atoms. So the option D is the correct option here. It is not a stereogenic, it is non-stereogenic. The option D is the correct option atom. And here, why I have said here non-stereogenic, this is because molecule itself is already a chiral molecule, right? So this is not a stereogenic. Stereogenic is like if you by making this carbon atom chiral, the molecule become chiral. If it is already chiral molecule, then definitely it is not a stereogenic center. And also some question they are given. I mean, the simple question. The next one is in absence of specific data, which of the following statement is definitely true? We need to identify which is true statement about the R-bromopentane. R-bromopentane. So we'll just draw the structure of pentane. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is the pentane, and at the 2 position there is a bromine atom is attached, and the configuration for this one is the R configuration, right? So let's say it has any position, but final configuration will be the R. It is dextrorotatory or it is levorotatory. See, if it is R configuration or the S configuration, we can't define whether if it is R, it is dextrorotatory or levorotatory. So the dextrorotatory and the levorotatory, these concepts are practical concepts. The dextro and leo, they are we can confirm this by after measuring the optical rotation. We can't say theoretically by just doing the numbering and doing the assigning the RS configuration. We can't assign that one in the whether it is dextro or leo rotatory. So that is definitely the two statements are incorrect and optically inactive. Since it is having the chiral center, so basically it should be the optical active. So this is the wrong question. The correct option is the D. So this is the just for understanding I have just given, that is, if it is R or S, it doesn't mean dextro or Leo. Generally, what people generally do mistake, if it is R, then they consider it as a dextroauditory. Though no, this is a incorrect assumption. So if it is having the R compression, then it may be dextro or the Leo. So this is the R and S. These are the theoretical, and dextro and Leo, these are the practical observations. And obviously there are some different questions. This question you can easily solve by just convert this structure into the convert this both structure in the form of Fisher correlation formula. If you convert this both to structure in the form of Fisher correlation, then you can easily identify any. You can easily get the one option from this one. Please let me interrupt in between if you have any doubt. Okay. And the next question is absolute comparison for the following molecule. So these are the some interesting question. Just need to identify the absolute comparison for these molecule. So these are the Alin system, right? So in this one, if you look at this carbon skeletal, see these are the carbon atom which has the bond like this and another bond, and let's say this is the downside and this is the above the plane. So and these two are in the plane in this format. So we just need to convert this molecule in the form of 3D structure, like we can convert it into in this form just by looking. If you look from this side or this side, it depends on you which kind of observation you want to in which format you want to see the molecule. So you can easily visualize this molecule by seeing from either from right side or left side. I will just visualize this molecule from right side. Then what I can see, this group is on the lower side, right? So if I look from this side, so I will give the numbering 1 2 both side. So in this one, the first numbering will be definitely for this carbon atom, right? And the second will be the this, and in this one, the first and the second, right? So in this way, this is the numbering, and we depend upon from which side we are looking. So we need to give the numbering to remaining numbering, like things. If I looking from this side or this side, depending on that, I need to give the lower priorities to the opposites remaining atoms. So if I look from this side, so the 1 and 2 will be to this, and 3 and 4 to these carbon atoms, these groups. So if I look from this side, I can see the 1 will be the on the top. This 2 is the lower side, right? Dot attached to the dotted line. So this will be the 2. And here, if I look from the this side, then definitely this is on the left hand side and this is on the right hand side, right? So the fourth group on the left hand side and the third group on the right hand side. So this is the structure. This is the arrangement of the atoms. So we just 1 2 3, this is the S. So in this way we can easily give the nomenclature. And in this one, remain just note, we don't interchange. what we generally do, we interchange the configuration. If it is S, then we can change to the R when the lowest 4 priority group on the horizontal side. But in this case, in this kind of isomerism, we don't exchange this one. Well, if it is yes, then we, whether it is on the 4 priority group on the horizontal side or the vertical side, we don't exchange it. So this is S remain S. And we can observe from this way also. If you want some wish to solve the molecule from this side, then definitely the numbering will be the 1 2. So this is left side, right? So 1, and this one will be on the right hand side, 2, and the back side will be the 3 4. So the upper one will be the 3 and lower one will be the 4. So in this way the numbering will be like this. And here also we can see 1 2 3. This is the S configuration. So we can visualize from this side or this side, it doesn't matter. At the end we'll get the same configuration. So the configuration for this molecule is the S. So the option A is the correct option. Does anyone have any doubt in this question? All right, we'll move toward the next question. Which of the following molecules form stable at room temperature? Note, at room temperature they have given. So we need to find which isomer from the atrope isomerism. So what happens generally at minus negative temperature, there is less energy or even single bond rotation as well. If there is single bond, then also the molecule found the difficulty in the bond rotation. Let's say here with the example of these three. So which of the following molecule forms stable atrope isomerism? In this one, right? So they have given some different examples, and at room temperature they have mentioned. So at room temperature, we can see here this molecule. Let's say this molecule, it having the chiral center. Where is the chiral center? So here we can see this bond, the sulfur which has the two oxygen, butene, and this, it may in this fashion, as well as the in this fashion as well. So the isopropyl like CH2 CH3 like this way. So these are the two isomers are present for this molecule, atrope isomers. So this will be at the room temperature as well, because of the steric crowding of this isopropyl group. At room temperature, this molecule can't rotate among this carbon sulfur bond. So this is also have the one kind of atropisomerism in this bond. And the remaining, if you see the example of in the second example, it doesn't have the it's also having the sufficient energy barrier because of this OH hydroxy group and this long chains. So this bond here also, here among this bond, and here with this bond, the bond rotation is get restricted. So this is also at room temperature as well. This molecule doesn't have the sufficient energy to rotate among the carbon-carbon bond. So this also in the form of the chiral molecule in the room temperature, or it show the optical rotation at room temperature as well, this molecule. If you look at the next molecule, it has the fluorine, and there are hydrogen are attached remaining. So there is not sufficient energy barrier in this molecule. So the hydrogen just attach here, but it can restrict the rotation of this carbon bond between these two benzene ring. So this doesn't possess the heteroisomerism at room temperature. And if you look at this is the Arlene system. So definitely this is not the example of the heteroisomerism, right? So definitely this is the incorrect one. So they have mentioned heteroisomerism. So these are the Arlene system. They are not belong to heteroisomerism. So the correct option should be have 1 and 2. Option D is the correct option here. So only the 1 and 2 has the correct at show the stable heteroisomerism at room temperature as well. The next question is the absolute compression for following molecule is. We just need to give the absolute compression for this molecule. And here, if you see the molecule, we can look from the any side whichever we are suitable. Let's say I'm comfortable from this side, then I will just give the numbering here. And see, these are in the horizontal plane. So benzene ring, and I can give the numbering to this 3, 4, 1, 2. So the 1, 2 will be the top, bottom. This fourth is coming front side. So this fourth will be like this, and third will be like this, right? And we just 1, 2, 3 our computation. So we just need to give the numbering, and we know the how to visualize the molecule here in this molecule. We can visualize from this way, or we can visualize from this way also. That also doesn't matter. So the correct compression is the R compression. So option B is the correct option, right? The next question is relative configuration of the molecule as per syn anti-nomenclature. So we just need to give the according to the syn anti-nomenclature, right? So here we need to give the nomenclature among according to the syn and anti. So here, let's say here hydroxy group are present, and here hydroxy group are present. So these hydroxy group are, if you see this is above and this is below. These are the anti, right? And if they are on the same side, then it will be the syn. If they are on the same side, let's say if hydroxy group on the wedge bond, so it may be the syn. And here we can see the fluorine atom, which is, so these are the anti and these are also the anti, right? So both are anti. So which option it has both having the anti? So this having the anti syn. Obviously, it is not the syn. So we can easily neglect the options. So many time in the competitive examination, you have to solve a question in this session because we just try to neglect the option which is not correct. So here you can see we don't require to give the nomenclature as well. We can just see this which the at functional groups. So OH and this OH, they are this is on the wedge bond, this is on the dotted bond. So it means these are the anti to each other. And if you compare between the OH and the fluorine, so this OH and the fluorine atom, they are also anti, right? So the anti, that is option C is the correct option. Anyone have doubt in this question? We'll move for the next question. Which of the following compound are not resolvable at room temperature? Non-resolvable means they are uh, in the form of racemic mixture, right? So we just need to in the form of racemic mixture, or they are optically inactive. So if you see this one, Oh, I have not mentioned the D option. What is the D option? See the here we can check options. So this is obviously the not optically active because it doesn't have any is bulky group. This one is bulky group. This is also bulky group. So obviously this is the resolvable, right? And if you see this one, tertiary butyl group, and hydroxy group. The other option, its optical isomer will be the hydroxy group. Here it is on the dotted line. The other isomer should have the hydroxy group on the front side. So at room temperature also, at room temperature, because of this group and this entirely bulky group, this molecule behave as a optically active molecule. So we can resolve this molecule in the form of its dextro and leo form, or the plus or minus form. We can remove this molecule. So these two options are the these are the resolvable. If you see last one, if you see this last one, it doesn't have the optical rotation. So this molecule is non-resolvable, obviously. And it also, if you see this molecule, which has the center of symmetry. I'll just check what is the what is the D option. So the D option is 2 and 3. These are the non-resolvable at 20 degrees Celsius. Non-resolvable. I think we have just right. This molecule for the center of symmetry, so this is optically inactive, and this is also. So the option 2 and 3 is only the options. So there is no other option. This is the probably the D option will be the 2 and 3. It should have D option because there is no correct combination they have given. So the D combination should be the 2 and 3, and which will be the correct option here. The question 6 is the absolute compression for the following molecule is. Oh, so here EZ or RS. So we first need to understand whether it is the RS compression, or I mean where it is geometrical isomer, or whether it is the what we can say, it's like chiral center, that kind of isomers. So here if you see this molecule, this bromine and this bromine, they both are in the plane, right? And both are the identical. But if you see here, this these bonds, which has the one carbonyl group, and for here there is CH2 group. So these two are the different, we can say, the groups. And there is a double bond which has the CH2 and C double bond O group. So we can see here these carbonyl groups, they are opposite to each other. That is CIS, cis and trans. We know, right? E and Z. So Z means the group should be on the first same priority group should be on the same side. and E is the same priority group should be on the opposite side. Here we can see the first priority on this one, 2. Here is the 1, and this has the 2 priority. So the same priority group or opposite side. So definitely it is E configuration, right? So the option A is the correct option here. This is the example of geometrical isomerism. The same next question is also the same. It has hydrogen. Which of the following statement about the stereochemical description for the C1 and C2 centers? They have given the C1 and C2 centers, and we just need to understand, give the correct option. C1 is the pro-stereogenic, while C2 is prochiral. Pro-stereogenic and prochiral. So what is definition of the pro-stereogenic? Can anyone just comment, or you can unmute yourself and you can just directly speak. So here you can see these both center are the pro-stereogenic center. You can just see the definition what is the of the pro-stereogenic center. If you see here, if you attach any different atom to this, or if you substitute the hydrogen, the compound may become the stereogenic center. So that's why it's a pro-stereogenic center. So the option which has the both C2 and C1 both are pro-stereogenic is will the correct option. So here we can see option C, both are the pro-stereogenic center, right? Here also given the both pro-stereogenic and prochiral. But if you see these options, these two carbon, these are not prochiral carbon atom, because the condition of the prochiral atom is not satisfied here. So we can neglect the option D as well here. Just click on this. So the option C will be the definitely the correct option, because these two carbons are the and if you see pro-stereogenic but not prochiral. So the option C is the correct option here. The absolute compression for the following molecule is this RS compression. You should be the perfect in this one. If you have any here, just the difference is the only they have given the lone pair, and we know the lone pair have the lowest priority always. So you just give the 1, 2, 3 numbering, and based on that you can just you can directly assign the whether it is R and S. So I will just leave this question for you, because it's just a simple question. If you want to, so I'll just give the numbering as well here. 1, the methyl group will be the this side chain will be the second, and this methyl will be have the third, and the lone pair will get the fourth priority. So the pH CH2 that group will be the second priority, then the CH3 and the lone pair. So this is the priority order. It has the first, second, third, and the fourth. And based on that, you can give the RNS nomenclature. The same here as well. Here the numbering for this one will the first priority goes to the carbon atom which attached to the double bonded carbon atom. Second priority will goes to the carbon atom which attached to the carbon which is further attached to the phosphorus, and third will be this one carbon which attached to the another carbon which attached to double bonded carbon. So you can just direct, and methyl group will have the lowest priority. So the 1, 2, 3, it's R. So the 1R will be the, sorry, here 1, 2, 3. If you see 1 divided by 1, 2, 3 carbon atom. Oh, the third carbon atom should be double bonded carbon atom right here. There is one between also one carbon atom. 1, 2, 3, and methyl will be the fourth priority. So the 1, 2, 3, it's yes. And here 1, this side chain will be the second, and methyl will be third. And if you look from this side, so it's also having S configuration. So I have shown this molecule, I have just saw from top side, and it's clockwise. Since I have kept the fourth priority group on the top, so I need to change the R change to S, because fourth priority group on the side of, on the our side, I mean on the side of side to which we are looking. So we just need to opposite the alter change the configuration. So this center also having the S configuration. So the option D is the here correct option. So these are the some questions. So does anyone have any doubt in these questions? Please let me know, or also you can feel free to discuss any whatever things you want to discuss about the thermochemistry or anything. Does anyone have any doubt in this one? If you don't have any doubt, I will just stop the recording better.